into a little bit of math. We'll talk a little bit more about how the course is going to run and my math lab and all that stuff in a few minutes. All right, so let's consider the equation y equals x plus 4. I want to fill in this table with 4 solutions to the equation y equals x plus 4, and we did the first row. Okay, so when x equals 5, you go up to your equation, you replace the x, with a negative 5, not a 5. Replace the x with a negative 5, so we have negative 5 plus 4 instead of x plus 4. Negative 5 plus 4 is negative 1, so our coordinate, x comma y, is negative 5 comma negative 1. So if I do the same thing with negative 2, I have y equals, instead of x plus 4, it's going to be negative 2 plus 4. Replace the x with a negative 2, and that is 2. So what is my point that's going to be on my graph? Negative 2, 2. Okay. For 0, we're going to have y equals 0 plus 4, which is 4. So my point is 0, 4. And then when x equals 3, y is going to be 3 plus 4, which is 7. So I have a point 3, 7. Okay. I'm going to plot these 4 points on the grid. First one is already plotted, negative 5, negative 1. Right? Left 5, down 1. And then I'm going to connect them with a straight line. So let's see, negative 2, 2 would mean go left 2, up 2. And then 0, 4, I don't go left or right at all, and I go up 4. And then 3, 7, right 3, up 7. And you can see that all those points are falling on a line, on the same line. Connect them. If you have a straight edge, go ahead and use a straight edge. Just try to eyeball it. So which quadrants does this line pass through? Anybody remember what the quadrants are? 1, 2, and 3. Great. Yeah. So 1 is the upper right. That's always the first one. So this is quadrant 1. And then you go counterclockwise around. So this is 2, 3, and 4. 1, 2, 3, 4. So that line lives a little bit in 1, 2, and 3. Does this seem like a little familiar to everybody? Things coming back to you? Graphing? Okay. All right, so we're going to review one more thing before I give you some problems to work on, and that's some solving an equation. So my equation has fractions in it. It's 1/2 x is equal to 5/3 times the quantity in parentheses x minus 65. So I have 2 methods. The first one would be to distribute that 5/3. Okay, but there's an alternative solution method that avoids much of the fraction arithmetic that we're going to see in the first method. So I'm going to go through both of these. Now in your packet, this is already written down, but I'm just going to write it out. So you could jot it down on the side, or you can just follow along with what's written in the packet. Okay, so if I start with my equation, 1/2 x, I don't really like this green color. It's hard to see. Okay, so 1/2 x equals 5/3 times x minus 65. Okay. I'm going to start by distributing that 5/3. So my left-hand side doesn't change at all, 1/2 x. 5/3 times x is 5/3 x. And 5/3 times negative 65 is going to be negative. How do you multiply 5/3 times 65? Yeah, so I'll do a little side work over here. I would do 5/3 times 65 over 1. Multiply the tops. 65 times 5 is 325. 3 times 1 is 3. So I have 325 thirds. All right, now I want to bring all the x terms to one side. So which side do you want the x's on, left or the right? Any preferences? Okay. Is on the right. Okay, so we'll bring the x's to the left. So I would subtract 5/3 x from both sides. Right, so over here, those cancel. And then I have to do 1/2 minus 5/3. Right, more fractions. Do some more side work over here. 1/2 minus 5/3. What do I need to be able to subtract fractions? Same denominator. Yeah, what's my common denominator going to be? 6. Okay, so my 1/2 is going to become 3/6. What's my 5/3 going to become? 10/6. 3/6 minus 10/6 is -7/6. So that's what I have over here. I have -7/6x equals -325 thirds. All right. Remember, your goal when you're solving an equation is to get the x by itself, right? So what I'm going to do to get that x by itself is multiply both sides of the equation by -6/7. Right? That's the reciprocal of 7/6. When you multiply reciprocals together, you get 1. So I'm going to multiply both sides of this equation by -6/7. So my result, -6/7 times -7/6, those are going to cancel. I get 1, positive 1. So on the left, I have an x. On the right, I have a negative times a negative, so it's going to come out positive. And when you multiply fractions, multiply the tops, multiply the bottoms. So I have to do 325 times 6. Can I do that in my head? 650, double it again. 1950? Good. Over 3 times 7 is 21. Yep, 1950, good. Okay, so there's my answer, 1950 over 21. Do 1950 and 21 have any common factors? Can I reduce it? $650 over 7? I think you're right. So if I divide by 21, well, that didn't help, but 1950 is definitely divisible by 3. Yeah, and so is 21. So 650 over 7 when you reduce that fraction. Oh my God, that was a nightmare. Who liked dealing with all those fractions? Anybody? No? Okay. So I'm going to show you another method where we clear the fractions in the first step. So you do one little step, all the fractions are gone, and then you solve the equation nice and simply. So we clear the fractions first we start by doing 1/2 x. Half x equals 5/3 times x minus 65. Okay, so we look at all the denominators. We've got a denominator of 2 and we've got a denominator of 3. What's the common denominator with those two? 6. So I'm going to multiply both sides of the equation by 6. That's the lowest common multiple of the 2 and the 3. So just put a big bracket around the whole side on the left and the right, and I multiply by 6. All right, what is 6 times 1/2 x? 3x, right, 3x. And then 5/3 times 6, what is that? 10, yeah, because that's like a 6 over 1, right? And you do 5 times 6 is 30, 3 times 1 is 3, 30 over 3 is 10. So that becomes 10 times x minus 65. So I did not distribute, right? I just multiplied the 6 times the 5/3. Now I can distribute the 10 and finish solving this equation. So I have 3x equals 10x minus 650. If I bring the x's to the left, subtract 10x from both sides. So I have negative 7x equals negative 650. Divide both sides by negative 7, and you end up with x is 650 over 7. Same answer we got above. Any questions there? All right. So you'll see that throughout the packet, after each demo, there's an answer key to the demo. You won't really need to look at this unless you missed class and you're doing this on your own, right? And then following that are activities. So I'm going to give you some time to work on these activities, practice some solving equations, practice some graphing, and then we'll come back together and talk about more stuff. So when you're solving an equation, the goal is to get the x by itself, and the way you do it is you think about what's being done to x, and you have to try to undo what's being done. So think about when you put your socks and shoes on. You put your socks on, then you put your shoes on. How do you undo it? What do you do first? You take your shoe off. So you have to undo it in the reverse order that it was done, right? Just like putting on socks and shoes. Put on the sock, you put on the shoe. To undo it, you have to take off the shoe, then take off the sock. Okay, so let's think about what's being done to x by following the order of operations here. Okay, so remember, you always do multiplication first. There's imaginary grouping symbols in a fraction. So here, x is being multiplied by 3. Then we're adding 9. Then we're dividing by 2. And finally, we're going to subtract 4. Okay? So the very last thing that was done to x is that we subtracted 4. How do you undo subtracting 4? Add 4. Okay? So that means that minus 4, a negative 4, and a plus 4, those cancel. And x plus 4 ends up on the right. On the left, we have 3x plus 9 over 2. Okay, so we undid one thing. Now let's look at what's being done to x still. X is being multiplied by 3. Then I'm adding 9. Then I'm dividing by 2. How do you undo dividing by 2? Multiply by 2. So I'm going to multiply both sides of the equation by 2. So on the left, the 2's just cancel because I'm dividing and multiplying by 2. They go away. So I'm left with 3x plus 9 on the left. On the right, I have to distribute the 2. So I'm going to get 2x plus 8. All right. So now I want to collect all my x's together on one side. So anybody care what side we put them on? Yeah, so we'll put them on the left side by subtracting 2x from both sides. Minus 2x minus 2x. Okay, so on the right, those 2x's cancel, right? And on the left, I end up with x plus 9. X plus 9 equals 8. Then finally, get the x by itself. You need to undo the adding 9. To undo adding 9, you subtract 9. So we end up with x equals negative 1. Okay, so I gave you an equation of a line that's so messy, right? It's so ugly, right? And the reason I did that is because I want you to solve it without using algebra. So I made it as messy as I could to try to make you not want to do it algebraically. Okay? So I have y equals this whole mess, right? So I'm just going to outline right? This whole mess in pink, right? So the equations I actually want you to solve have the exact same mess, right? It's the exact same thing. Those are the same, right? So the only thing that's changed is instead of a y, instead of a random letter y, now I have a number 5, right? So if I look at the graph of y equals the mess, right? What I'm looking for is a point on this line that has a y coordinate of 5. So y is 5. There's a point on this line that has a y coordinate of 5. It's something comma 5, right? The x coordinate is going to be the solution to this equation. So you go down, looks like at negative 2.6 maybe, negative 2.7. That makes sense? So then for the next one, you're looking for a point on the line that has a y coordinate of negative 1, like right there. And you want the x coordinate. That will be your solution. I'll let you do this, the last two on your own. For C, instead of y equals all of this mess, what I'm trying to solve for C is I replaced that y with a 3, right? So I now know the y coordinate of the point I'm looking for, and I would like to know the x coordinate, right? I want to solve for x. I know the y coordinate is 3. So I want to find a point that's on this line that has a y coordinate of 3. So I'm going to find, here's y equals 3, right? This line right here, every point on this line has a y coordinate of 3. And there's only one point, this is the line y equals 3. There's only one point on that line that is shared by y equals all that junk, right? So there's this point right here is on my line, the graphed line, and it has a y coordinate of 3. What are the coordinates of that point I just drew? 0, 3. I didn't go left or right, I went up 3. 0, 3. So the x coordinate of that point is the solution to the equation. Right? So in this case, x equals 0 is the solution. All right, so let's see, I'll do the other one in a different color. Now I'm replacing my y coordinate, I'm replacing y here. Shouldn't make it an x. I'm replacing y with 0. Okay. So I'm looking for a point on my line that has a y coordinate of 0. So let's see, right here. What are the coordinates of that point again? Good. What are the coordinates of this point? Switch it. 2.5, 2.6, 1, right? So I'm looking for a y coordinate of 0. Neither of those worked yet, right? This one was 0, 3. The y coordinate was 3. Here my y coordinate is 1. Right here, the y coordinate of that point is 0, right? What are the coordinates of that point? 4, 0, right? So I found a point on my line that has a y coordinate of 0. Its x coordinate is the solution to the equation. So this one is x equals 4 is my solution. All right, so lesson number 2 is where we first start to tackle some word problems. Okay? So we're going to see a powerful technique for starting word problems today, and that is to pick a random number to try to figure out how to use your variable or your unknown. Okay, so just a quick reminder here, the expectation is that you're going to work diligently on math for the entirety of each class period that we have together. You're expected to get through all of the demo, which I'll be doing in front of the class, plus all of the activities. And sometimes that will mean finishing the activities outside of class time. The even more practice section is optional. It's there for people who want additional practice or if you finish the activities in class early. Okay, if you finish the activities early, continue working diligently and get through as much of the even more practice as you can. Make sure if you answer a homework problem on my math lab and you really think it's right, but my math lab says it's wrong, send me an email, right? And I can go in and check and right away give you credit or not, or tell you, no, your answer is actually wrong, right? Don't let yourself get too frustrated. Send me an email right away. All right. I prefer the GCC one. It goes to junk less frequently, and there's like some privacy issues that I'm not actually sure it's you when you send me an email from something else. Okay, so sometimes when we're asked to write an algebraic expression to describe a situation, we may not know where to begin. Many times we know how to do the problem if we had numbers, but we don't know how to create the expression. So let's see how we can use numbers to try to find a pattern that will help us write the algebraic expression. So for example, this is from your textbook. The price of a 7-day Alaskan cruise, normally $2,752 per person, is reduced by $1.75 per person for large groups traveling together. How large a group is needed for the price to be reduced to $2,500 per person? So I've got this table, and I've chosen two random numbers, 10 and 50. What if you had a group of 10 people, right? What would the price per person be? What if you had a group of 50 people? What would the price per person be? So for 10 people, we would say, okay, we get 10 discounts of $1.75. So that means our savings is going to be 10 times $1.75, or $17.50, right? Is going to be our savings. That gets subtracted from the original price of $2,752. $2,752 minus $1,750 is $2,734.50. So that's our cost per person for the cruise if we had 10 people in our group. That's not low enough, right? We want to get down to $2,500 per person. So what if we had 50 people in our group? We would get 50 discounts of $1.75, right? So our discount amount is going to be 50 times $1.75. Put my calculator here. $87.50. So that's our discount amount. Right? And then we subtract that from the original price per person. So 2,752 minus 87.50. And I get 2,664. Right? Still not low enough. I want to get down to 2,500. Okay, so quick detour. A quantity is anything that can be counted or measured. Length, weight, area, number, volume, time. A unit is a fundamental amount of some quantity. Inches, pounds, square meters, cars, cubic feet, hours. If you have a quantity word and a unit word and you don't know which is which, put a number in front of one. And the word that makes sense with a number in front of it is a unit. Okay? So for example, we've got two words here, time and hours. Which one is the quantity word and which one is the unit word? Yeah, time is a quantity and hours is a unit. Right? Because if you put a number in front of time, 9 time, that doesn't make sense, right? But 9 hours makes sense, so hours is the units. Okay, so I want to use a quantity word and a unit word to carefully define the variable that I'm going to put in the third row of this table here. So I'm going to let X be the number of $1.75 discounts I'm going to get. That's the number of people in my group going on this cruise. Okay. So the number is the quantity word, and it's mandatory to include a quantity word when you define a variable. Okay. So If X is the number of $1.75 discounts, then the cost per person, right? My discount amount, I get a discount for every person, 1.75x, right? And I subtract that from, what was my original price? 2,752, right? That's my new cost per person. So in my table before, when instead of an X, I had a 10 and I had a 50. Right now I'm just using an X because I don't know how many people there are. Set that expression equal to 2,500. And now I can solve for the number of people I need to bring on this cruise to find out when my price will come down to $2,500. So I'm going to start by subtracting 2,500 from both sides. Oh, let's see. My instructions say subtract 2,752. All right, so 2,500 minus 2,752 is negative 252, and then I'm going to divide by 1.75 negative, and I get 144. I didn't show all the work. I'm sorry. I'm trying to rush a little bit. X is going to be 144. So you need a group of 144 people to go on this cruise together in order to get a price of $2,500 per person. Yeah. Yeah. So solving real-world problems involves creating equations that represent the problem accurately. In order to solve realistic problems, we have to be able to take the given information and translate it into an algebra equation. This takes a lot of practice. It's a knack that you develop with practice and time. Okay? But the main thing to take away from what we did today is if you don't know where to start by just picking some numbers and see if that gives you some insight. Right? Don't jump to defining a variable, but instead say, well, what happens if I have 10 people? What happens if I have 50 people? Do that 2 or 3 or 7 times until you get some insight about what is actually changing. Call that thing X, right? And then try to set up an equation. Okay, so keep that in mind as you start the activities that we're going to work through on Tuesday. So we will start class here on Tuesday with these activities.